Trista Pan, who will be talking to us about how to perform cloud migration by leveraging Apache ShardingSphere database mesh capabilities. And just for context, before I finish introducing Trista, the idea of UXDX is to pull together product, UX, design, and dev. So this is going to be a more technical talk, but the purpose is exactly what we were just talking about in the last session. If you can build your T-shaped skill, if you can understand a bit more about what's happening in some of the other parts of the product development lifecycle, you'll be able to contribute better as a team member, and it kind of builds that generalist capability. So with that kind of introduction, I would like to introduce Trista, who will be sharing her story. So welcome, Trista.
Hello, everyone. Yeah, so wait a moment, let me share my screen. All right, so hello everyone. I agree with that. We discussed in the previous talk that no matter it's about the product or about the tech part, actually, if we can, share our ideas, make us in the same page, then that will be great to make the cooperation between the product team and the tech team to work together. So today, my talk actually it's a little tech part because you can see this topic. It's about your database. It's about the distributed system. It's about the Kubernetes. So when I mention 3 hot words today, people will consider that, oh, it's a little far from my work. But today, actually, I just want to make this topic become a little more product, right? So I just gave the introduction about this solution, about what is happening in the database and in the Kubernetes in this distributed system. So if you are a product manager, and that will be great for you to get such the useful messages for your company's product, or for you to give some suggestions for the other team members, right? So let's get started with my talk, because today I only have 25 minutes. So in this slides, there is a demo show. I have no time to introduce the demo. If you're interested in the demo, I guess you can later on refer to this slides and to do the demo by yourself, right? So today we will just focus on the solution and focus on the 3 keywords: distributed system, database system, and Kubernetes. This profile, it's about myself. I'm the Trista Pan, and now it's the Sophia co-founder and the CTO. Also because I spent a lot of time in the Apache open source software foundation. So I'm the Apache member and the incubator project mentor. That means my role actually is a mixed one. Sometimes I need to help our tech team to do the technical development part. The second one, because our product or the company's product, it's about the infrastructure, databases product. So sometimes I need to switch my role to be the product manager to help to design the database distributed system from the product manager perspective, right? So that's my role, and now I'm the ShardingSphere PMC, ShardingSphere project. It's a top level project of the Apache Software Foundation, and today we will leverage this project to introduce how to use it for your distributed database system on the Kubernetes. Sometimes I will post some articles about the open source, about the community, about the product, about the tech part around all the stuff. So if you're interested in such topics, you can just give a look on my Twitter or LinkedIn, right? Today, first, let us get into the background about digital transformation, because I guess everyone know this word. I mean, digital transformation. People want to leverage the new technology to help them to provide them more productive and the great product to our end user, or totally change the delivery paradigm, or to change the delivery culture, all the stuff. So that's about the digital transformation. First, about the new technology. Second one, it's the paradigm, or it's the culture change. So that's the background. Because of this background, people actually have the new needs for our database system and for our cloud. Because you know that nowadays, when people into the big data, I mean, in era, right? So you found that your databases, maybe you found your website visiting becomes so slow, right? So why it becomes so slow? Because your databases need to help you manage the random data, right? So, and in that the situation, how to make your database product to support your visiting from your application, from your website, and how to make it become secure, and how to make it become the skill in, skill out, elastic skill, all of the new needs from the big data, from the digital transformation background. Here, I list the people's new requests for your database system, the large data to manage, the efficient queries, and you need to do the traffic governance, and how to reach the elastic scaling goal, and an out-of-the-box deployment, right? So that means at the beginning, maybe you have your good PostgreSQL or MySQL. They're so great, work on the premise or on the cloud. But now you need to do some change about this database infrastructure. So in order to reach such goals, actually you need the following technique. First, data sharding. I mean, data sharding means that at the beginning, you only have the one single database, right? But now you want to make the single database is split it into a lot of small portion, which will be located in different machine or different location. And that's one about your traffic governance. That means you need to improve the high availability of your system, and to governance your each queries, to leverage your replicas of your databases, to make the throughput become higher, right? And that's one about reshard. That means you want your database system can have the elastic scaling feature. So your new database system can help you to reshard your databases. And that's one that we can use the Helm or operator on the Kubernetes, this mature and wonderful platform or cluster to help you manage your database cluster, and to also at the same time retrieve the 3 points, 3 points, right? So that's the new needs, and we need to the new technique. And now we need a solution to help us to include all of the new technique into one solution. I mean, that means this solution can provide the out-of-the-box a product or project for you just to use. So the next part, I will introduce how to present this solution for you to reach the following new requirements. I need to first give the brief introduction about our monolithic database, because if we want to solve the issues, we need to first consider what's the database, and then we use the database's functions to upgrade it, become the current modern database system. So what's a database? Actually, there are two major functions of your database system. The first one, computing capability. The second one, storage capability. So for the monolithic databases, for example, PostgreSQL, actually each of them have the computing capability and the storage capability, but they will put two of the layer or two of the components to work together in the same machine. That means they are monolithic databases. But in a distributed database system or in a sharding database system, actually the computing components and the storage component, they are distributed in the different locations in this world. So that's the major difference between the monolithic databases and the modern distributed or sharding database system. So now if we want to make our traditional databases to upgrade, become a distributed one, that means we need to split the computing nodes or the storage nodes into different machine or different locations. So that's the approach to solve this issue. That means before, maybe your database infrastructure like this one, your application just visit directly with your PostgreSQL or MySQL cluster. Visit here or visit these primary nodes or replica nodes. But now, if we want to, like here after, you will have this modern database infrastructure. How to reach that? That means we need to import another component between your application and your traditional databases. So your application will just visit this new component. And this new component, it will work as a computing node of this distributed database system. And your traditional databases at this point, it will become the storage nodes of this distributed database system. That means this new component plus your traditional databases will become a new distributed database system. And in system, the new component, it's a computing layer, and your traditional databases, no matter it's a MySQL, Oracle, or SQL Server, or PostgreSQL, will act as the storage nodes, right? So that's the new solution. Because we use this new one, we can upgrade your previous database infrastructure, become a distributed one, and your application can just visit this computing nodes or this database proxy. And this database proxy will help your end user or application to manage all of your thousands or hundreds your databases cluster. And you don't need to care about the auto-scaling or about the traffic governance or about the data sharding. All of the features will be taken over by this database proxy or this computing nodes for your application. Your application just think that there is a distributed system, and it will don't care about all of the technical details about how to auto-scaling, how to do the traffic governance, how to do the how to input the high availability of this database system. Now, all of the features are transparent for our application. So here we use this, we leverage the new components and make the new component merge with your traditional databases and make it become a distributed one. What's this new component? That's the ShardingSphere. ShardingSphere is the Apache top-level project. Actually, you can see here slogan, ShardingSphere, it's a ecosystem or it's a proxy to transfer your any databases become a distributed one and enhance it with the sharding feature, elastic scaling feature, or data encryption feature. So by using this ShardingSphere proxy project, then we can upgrade your traditional MySQL or PostgreSQL database become a distributed one. Actually, ShardingSphere has been open sourced for more than 5 years. So you can see here, this project has a mature community. We also have like more than 400 contributors and already released for, nearly 50. So I guess if you have any questions, this community will answer your question, will provide their help as soon as possible. And his document also can help you to quickly set up this project for your environment. Yeah, so by you this one, and we can upgrade your database system, existing database system, become a distributed one. Actually, this project provides 2 clients for end user to choose. First one named ShardingSphere JDBC. It's for your Java, application. It's a lightweight Java driver. And if your application was developed by the Java, then you can just use the Maven artifact and use this client, and it can help you to do all the features I mentioned before, and it can upgrade this all of the databases become a distributed one and help or any user or your application to manage all of the database cluster. The next client is ShardingSphere proxy. ShardingSphere proxy, it's a database proxy. It works as the database server, distributed server. So you need to deploy the ShardingSphere proxy in a single machine. That means, look here, compared to the JDBC, it needs to be deployed independently. And JDBC just need to independent with your application together, right? So ShardingSphere proxy, you can just use your MySQL protocol or your PostgreSQL, the third-party connection approach to connect to ShardingSphere proxy, and that means it will not totally change your previous way to connect your monolithic databases, right? And then it's actually ShardingSphere proxy, Sharding JDBC, they share the same features like I mentioned before. They are just the 2 clients for you to choose. So if you, no matter you use ShardingSphere JDBC or ShardingSphere proxy, it can help you finish the following features: data sharding, elastic scale out, and distribute transaction, rewrite splitting, and authentication. All of the security issue or data sharding issue or scale out, scale in issue, right? But today in my demo, I just use ShardingSphere proxy and to help user to solve the data distributed issue. That means the data sharding issue. Yeah, so the next part, I will give the solution actually, because I mentioned a lot about this architecture of your new database infrastructure. The next one, that how do we efficiently deliver this product to our end user? That means we need to use the Kubernetes system. Here in this repo, ShardingSphere on Cloud, it provides many ShardingSphere charts. That means you use Helm, then it can help you deploy ShardingSphere cluster and ShardingSphere operator into your Kubernetes system. That means you can just use a few comments on your CLI then you can do some of the demo for testing. ShardingSphere charts, it can help you deploy and upgrade ShardingSphere cluster, and ShardingSphere operator. It can guarantee the high availability and scale out the HPA of ShardingSphere clients. So there are different charts for the different functions, but we recommend you can use them together. So you don't worry about from the deployment to upgrade to HPA, high availability, all of the features, right? So we recommend or end users use them together. All right, so that's all about today's solution. And next part, I mean, if you use ShardingSphere charts to deploy ShardingSphere on the Kubernetes, and that part, maybe you need to use one of the PostgreSQL charts to deploy your Postgres on the Kubernetes. That means by use PostgreSQL charts, you have your storage nodes, and by use ShardingSphere charts, you will have your computing nodes. So, like I mentioned before, your computing nodes plus storage nodes will become the final distributed database system for your application, right? So for your application, they can just use the previous approach to connect to this new database distributed system, and to help you do the database sharding and improve the throughput, and also can make each query become faster than before. So that's all of the capabilities of this new database system. And now, for example, you deploy PostgreSQL here, and also about ShardingSphere, and your application just visit the ShardingSphere proxy to tell ShardingSphere proxy and your databases that, hey, I just want to split this T order table become the 1, 2, 3, 4 subtables in your database system. Could you help me do the data sharding, or could you help me do the rewrite splitting? You can just tell the ShardingSphere all what you want by SQL, and then ShardingSphere proxy can automatically to deal with all of your requests from your end user, and to manage your databases, and to do the global computing for your each query. So the next part, handle process over SQL. That means, your application just send your queries to this ShardingSphere proxy, and ShardingSphere proxy by use some sharding algorithm or some the strategies to help you find the target row or target record, and get the record to do the global computing and send the result to your end user. So even though we upgraded by using ShardingSphere proxy, but the process of the SQL actually have no changes compared to the previous one, because for database system, we don't change his computing power and the storage power. We just make it become stronger, become more powerful. But actually, for the handling process of a SQL, they are unchangeable, right? Okay, so that's all about the solutions introduction. The next part, it's about the demo show, but we have no enough time to introduce them step by one step. But actually, I want to see that I gave each steps for you to refer to these slides to do the demo by yourself. And you can see here, for example, here, if you, here you execute the SQL, this one from the ShardingSphere proxy, then you can get the result right here. But if you log in your actual storage nodes or PostgreSQL instance, you will find actually you will find that in your actual databases, there are many, sub-rows or sub-readout from each PostgreSQL instance. So that's the function of our ShardingSphere proxy. It will hide all of the sub-readout or the actual rows. It will just give you the final readout, so people will no worry about all of the the middle readout from this database system. All right, so that's all about today's talk. Yeah. So any questions?
Hi, Trista. Thank you for that. I think you covered that in quite a bit of detail, so it was interesting to see. And it's a problem that people might not be aware of happens as frequently, where your database just kind of starts getting slow, and you have to figure out how to solve it. And one thing that did come to mind, and a question that came up, is what would be the benefit, and when should companies start looking down this kind of sharding route, or maybe looking at a less hands-on, maybe migrate to Cockroach DB or something like that, where the database itself and the hosting is kind of managed elsewhere, a serverless host, maybe Aurora or something like that.
All right. Okay. So actually, when we see the Cockroach DB or other, distributed databases, they also use the same technique here, like the data sharding, because Cockroach DB also have a lot of the distributed instance. But here, the major different one, that is your Cockroach DB, their storage layer, they use another storage components like a KV or other storage types. But here, this solution, it also share the sharding technique, but it use your traditional databases to work as the storage layer. So the benefit from today's solution is that because if you want to choose distributed databases, for example, the Cockroach DB or Aurora databases, that means you need to migrate your original, all of your data into a new one, right? So that's a danger, action for our DevOps team or DBA, right? But today's solution, you don't need to do any change about your previous database cluster and just import your a new computing nodes in your previous database system, so you can share the same data sharding technique with the new databases, the Cockroach databases or Aurora. So I guess for any users, you need to base your scenarios to choose all of the types of databases. And if you want to, just develop from the scratch, right? So it's okay for you to choose Cockroach DB or the Yugabat DB or the Aurora databases. That's fine. But if you are a little worried about that, if I don't want to do anything to my existing databases, I just make it upgrade, then you can choose today's solution.
Great. No, that's a great answer, and thanks for clarifying, because migrating your database is no easy feat.
Yeah. Thanks.
So I think that brings us to the end. So thank you very much for sharing, and really enjoyed the talk, and I hope everybody out there did as well. So thank you very much.
Yeah, so see you next time, guys. I'm sorry you can endure this tedious plot to listen to this text speak. Thanks, everyone.
No problem. Thank you.